Okay, the approach of a South Pole magnet. Okay, from above the page. So let's look at that, right? So let's draw a picture of this from the side. Here's our South Pole magnet. And we know that it's approaching this loop. And of course, if it's approaching, you don't want that magnet to approach. Do we want that magnet to approach? No. Okay, so what it's going to do is it's going to create a south pole on the top and a north pole that way, right? Okay, so the way to create a south pole out of the page is for the current to flow clockwise. Okay, so let's go over that again. The south pole magnet is approaching, right? We don't want it to approach, so the way to repel it is to create a south pole that repels that, right? The way to create a south pole is for the current to flow clockwise, and that creates a south pole out of the page, right? Okay, so clockwise. And then, let's see, the current is 12.5 amps. What is the induced EMF, and what is the resistance of the wire? In what direction did the current flow? Oh, okay. It looks like we can find the EMF by just using this, right? The number of windings times B times A over T, right? And I think there's just one winding. And then the change in magnetic field. So this is a change in magnetic field, right? And they're both out of the page. So it's going to be 3.6 minus 0.105. Our area it's a square, so it's 0.48 squared, right? And then our time is 0.0150 seconds. All right, so let's figure out the EMF here. We can do this. 1 times left parenthesis 3.6 minus 0.105 right parenthesis times 0.48 squared divided by 0.015. And it's 53.68. Okay, now the current is 12.5 amps, so we want to know what is the resistance of the wire. We already figured out that the current's going to flow clockwise. We figured this out. How do we figure out the resistance? And resistance is at V over I. I think it is, yeah. Right, so 53.6832 divided by 12.5 amps. So I'm going to divide the number on my calculator by 12.5, and I get 4.29 ohms. 4.29 volts per amp. No place like ohm. All right, and clockwise.